Hi. So in this video, I'm going to teach you what is called the method of induction. I have already written the statement of it. It's little different to what is taught in your class. Different in the sense this is more general. Uh, Let me highlight this. So in this, usually what is taught in your class, I assume is if the statement is true for n is equal to 1, and if the statement is true for n is equal to 1, that is p, and instead of n0 you take 1, and then if it is true for all k greater than equal to 1, the truth of pk implies the truth of pk plus 1. That is, if pk is true, then pk plus 1 is true, then p Pn is true for all n greater than equal to 1. Instead, we have taken n0 to be, instead of 1, you can take any other integer as well. Okay, so that is the difference. But what we do is we take a statement Pn, which is a statement for each natural number, and we first do it for any n0, and then if for any k greater than n0, the truth of pk implies the truth of pk plus 1, then pn is true for all n greater than equal to n0. So that's what to do. Let me highlight this using some example. So first example I take is we have to prove that sum of first n natural number is this one. Okay. So this is my statement, that this statement is sum of first n natural number is given by half n into n plus 1. Okay. So let me prove it. So in this case, I am taking from n0. N0 is equal to 1. Okay. So I will prove for all n greater than equal to 1, this thing is true. Okay. So first for P1. P1 is 1 is equal to 1. If you put here 1, 1 plus 1 by 2, then you can see this is 1, right? So this one matches, right? I have put n is equal to 1 here, and we just take the first number 1. Okay. Now pk will be, we assume that pk is true. Okay. For k greater than equal to 1, right? Here, k greater than equal to 1, because n0 is 1. So that is pk is true, means 1 plus 2 plus 3 is equal, plus k is equal to k into k plus 1 by 2. Okay. And we want to prove that pk plus 1 uh, is true. That we have to show. Okay. If we can show it, then our statement is valid for all natural numbers greater than equal to 1. Okay. So how do we do it? What is pk plus 1? What does it mean to be pk plus 1 is true? That is 1, 2 till k plus 1 is equal to half k plus 1, because instead of n we should take k plus 1. Okay. So this will be k plus 2. First we know that this one is true. Okay. So in this equation, add k plus 1, add k plus 1 both sides. Okay. So what will you get? You will get k plus 1, this thing, plus k plus 1. Okay. So this one we get to be 1, 2 till k plus 1. Okay. And this one you will get, uh, you can k plus 1, and then if you take common 2, then this will be 2k plus 2. Okay. And that is equal to k square plus k, and 2k plus 2 by 2, which is k square plus 3k plus 2 by 2, which means this you verify, this is equal to k plus 1 into k plus 2 by 2. Okay. So this one is the first example. Okay, so this shows that pk plus 1 is true, and so by this principle of mathematical induction, we can claim that this pn statement is true for all n greater than equal to 1. Okay, now let me wait for 1 2 minutes, and we will I will show you another example. Okay, Mm, let's take this example. Okay, let r be a real number and r is not equal to 1, and n belongs to natural number. Then 1 plus r square till Rn is equal to 1 minus Rn plus 1 by 1 minus. Okay, this I want to show that this is true for all n belongs to natural number, that is all n greater than equal to 1. Okay, natural number. So this is my Pn. So first I will show P1 is true. Okay, so first number, this is, can you recognize this is actually your geometric series? Okay. Anyway, so what is P1? For P1, is it true? 1 is equal to 1 minus R, and sorry, this is 1 plus R, right? So this will be R, and if you put 1, 1 plus 1 by 1 minus R, is it true? Yes, it is true. 1 plus R. You take here 1 minus R. This will be 1 minus R square, right? So this one is true, right? Both sides are equal. So P1 is true. Okay. Now let's assume Pk is true. That means 1 plus R square till R k. This thing is true. Okay. And I want to show that Pk plus 1, this we take to be true. Okay. I want Pk plus 1 is true. That is, we have to show this till Rk plus 1 is equal to 1 minus R k plus 1, that is k plus 2, 1 minus R. Okay, this we have to show. So what you do, you add k Rk plus 1 both sides to this equation. Okay, so if you add, you will get this, then 1 minus R k plus 1 1 minus R plus R k plus 1. Okay, so this will be 1 minus Rk plus 1 plus R k plus 1 minus R k plus 2. Okay, 1 minus R. I have taken 1 minus R common denominator. Okay, so this one cancels, and you will get 1 minus R k plus 2 by 1 minus R. Okay, so we have shown that Pk plus 1 is true. So this Pn statement is true for all n greater than equal to 1. Okay, now I think I will wait for another few seconds, and then I will prove what is this assignment, your assignment question number 1. Okay, I think it is n is greater than n is smaller than 2n. That is your question, right? Just wait a few seconds. I need to log in. Where is your classroom? Calculus 1. This is your assignment. N is smaller than 2n. Okay. So this is also we have to prove for all n. Okay. So let me write it. We have to. So this I have to prove. Okay. So first I will take n is equal to 1. Then 1 is greater than, sorry, 1 is smaller than 2. This one is correct. Okay. Now let's assume pk is 2. That is k is less than 2k. And I want to prove that k plus 1 is less than 2k plus 1. Okay. So this one is true and this one we have to verify to prove. Okay. So again, you just add 1 both sides, k plus 1. This will be 2k plus 1. Okay. You are adding 1 to both sides, and then k plus 1 is less than 2k plus 1 is less than 2k plus 2. Okay. Is that uh, are you happy with this 2k plus 2? Because in fact, I think before this, okay, I think, do you know that 2k is greater than 1 for all k? This one I want to prove for all k belongs to natural number. This one first I need to prove. Okay. So this one also we can use induction. Okay. First k is equal to 1. This one is true, right? 2 is greater than 1. For k, you assume 2k is greater than 1, and 2k plus 1, I will use, I want to prove this. Okay. So how do you do? You multiply 2 both side here. This one is true. You multiply 2 both side, then you will get 2k plus 1 is greater than 2. Okay. And that is greater than 1. So you have proven this statement. Using induction, you can say that this statement is true for all k belongs to natural number. Okay. So now I'm going to use this one here. That is 1 is less than 2k. So I can do this. So you will get 2 into 2k, that is 2k plus 1. So this statement reduces to k plus 1 is less than 2k plus 1, that is equal to 2k plus that is less than 2k plus 2k, and that is equal to 2k plus 1. So consolidate this one, you will get this one. Okay. So let me rewind. So what I did is I proved using induction, I proved this one first. Okay, that 2k is greater than 1 for all k comes to natural number. For k is equal to 1, this is clear. For k is equal, for k pk, this one we assumed is true, and then I showed um, this is pk plus 1. So this statement is 2k plus 1 is greater than 1. Okay, this one I want to prove. So what I did is I multiplied by 2 both side to this I want to prove. So I multiplied by 2. So 2k plus 1 is equal is greater than 2, and which is greater than 1. So this is what I needed to prove to show that this one is true. So this one, once this one is true, then I used it here. Okay, to prove that this pk plus 1 is true, that this statement. Okay, so we are done. Okay, thank you.